Hello everyone. So in this video we are going to create a mini project in Angular, that is DSA visualizer. In particularly in this project we are going to build the tree visualizer. So let me first explain you what we are going to create. Okay. So first the UI part. So our UI will look like something like this. So this will be our interface where we will accept the level order traversal of a complete binary tree and then the number of maximum childs a node can have. So for example, this is our tree. Let's say 1, 2, 3, null, and 4, and then null, and then 5. So we want to create a tree like this. So you can see a node can have maximum of 2 child. From the given tree you can see it. So the maximum number of childs a node has is 2. In the input we will restrict it to a minimum of 1 and a maximum of any. Okay. So the level order traversal of this tree will be 1, 2, 3, null, 4, null, 5. So if someone gives us this string, we should be able to build this tree. Okay, so let's see if we are able to build this tree using the given string 4 and 5. So before going into creating this application, we should be able to know how to create a tree out of the given string. Okay, so this is the input that we got. Now we have to build the tree out of it. Okay, so first the root node, that is 0. So index is 0, 1, 2, 3, 4, 5 and 6. So the root will be at 0th index, that is this. Now we will use the recursion to build this tree. So first we'll insert the node 1, that is at index 0, which will be the root. Now the left child of this tree will be at 2 into index plus 1, and the right child will be at 2 into index plus 2. So we will recursively build for the left child. So what will be the left child of this tree? That is 1, and the right child will be at 2. So first we will insert the left child, that is 2. Now since we have inserted the node 2, we will call the same function for the node 2. So for the node 2, what will be the left child? The left child will be 3 and the right child will be 4, right? So we will insert the left child, that is null. Now we'll go back to 2 and we will call the recursion for the right child. So the right child is 4. So we'll insert the 4. Okay. Now we will call the same function for the node 4. So at the node 4, what will be the left child? That is null again, and the right child also null. So left and right childs are null. Okay. I'll go up one level, we go up one level, and at 1, since we have called the for the left child, we will call for the right child. So at 1 index 0, we called for the left child. Now we are calling for the right child. So the right child is 3. Okay. Now we have inserted 3. Now we'll call the same function for 3. So for 3, the left child is 5 and the right child is 6. So we'll insert the left child, that is null, and since it is null, we'll go up one level and we'll call for the right child. So for 3, we called for the left child, that is this null, and now we'll call for the right child of 3, that is 5. So we inserted 5. Now after inserting 5, we'll call the same function for node 5, that is this node, and we'll see that the left child of this is null and the right child is also null. So we'll insert null and null. Now if you see this tree and the tree that we have built is same. So you see there is these leaf node, these are null, and the tree is exactly as what we have built. So now let's see what this input string is able to generate by giving a particular string. Okay, first let's see why these two. Okay, so I told you that we will accept the two inputs. The first one is the level order traversal of a tree, and the second is the number of, or I can say the maximum number of childs a node can have. So let's say I want to create a tree something like this. So this project is able to generate every kind of tree. So that's why we are accepting two inputs. So let's say I want to create this tree. which has 1, 2, 3, then 4, 5, 6, then let's say 9. It has only one child. Now, if I want to create such a tree, what should be my input? First, you can see that the maximum number of a child a node can have is 3. So our second input is 3, that is number of childs. And the first input is obviously the level order traversal. So the level order traversal is 1, okay, 1. Then the second level, this is the second level. So a maximum number of childs a node can have is 3. So the root is 1 and it has 3 childs, that is 2, 3 and 1 is null. So I have to decide which one you want to make null. So 1, then we have 2, then we have 3, then we have null. So this is the second level. Then at the third level we have 4, 5, 6. Then at this 3 we have, that is null, null or 9, or you can insert 9 anywhere because it has only one child. Okay, so you can say something like 9, null and null, and you can remove these two nulls because these are later part which will already be guessed by the algorithm. So finally we will have these null 4, 5, 6, 9, and you can omit writing null or you can say null and null. So this is our second level, first level and zeroth level. Now let's create the same tree using the algorithm. So at the root we'll have 1. So the index are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So at 0, zeroth index we have the root. Now the left child will be what? Is it 2 into idx plus 1 or something else? So you see this 2 comes from number of childs. So here the number of child is 3. So it will be 3 into idx plus 1. Since it is 3, we'll have 3 into idx plus 2. 3 into idx plus 3. So we'll have these number of childs. So the first child will be 3 into index plus 1. Second is 3 into index plus 2. And third child is 3 into index plus 3. So 3 into index plus 1, that is this, second child is this, and third child is this. So the first child is going to be 2, second is 3, and the third child is obviously null. Then the left child of 2, this is 2, this is 2, and the left child is 3 into index, that is 3 plus 1, that is 4, second child is 5, and third child is 6. So it will be 4, 5, and 6. Now at 3, the left child is 3 into 2, 6 plus 1, that is 7, then 8 and then 9. So for 3 it is 7, sorry, for at index 7 it is 9. It is 9, then it is null, and then it is null, right? So you compare with the tree that we have built, that is 1, then 2, 3, null, then 4, 5, 6, 4, 5, 6, and then 3, we have only one child, that is 9. Okay, so here you could have said something like 2, so it will be 9 and 2. So that's how we are going to create the trees in this project. Okay, so now as I said, these two inputs, that is the input that is the level order traversal of a complete binary tree and the number of childs it has, these two inputs will help us create any kind of the tree. And finally, we will implement a functionality to save the tree using a PNG format so that we can use it anywhere. Okay, so without any further ado, let's start implementing this tree. So I'll be using Angular 19 for this project. You can use whichever version you wanted to use, but I would suggest you should use the latest version. The latest version as of now, I think it is 21. I'm not sure, but if you prefer any particular version, you can go for it. But I will be using Angular 19. Okay, so let's see. Okay, so this is my monorepo application. So in your case, you will be creating this as a fresh application, but I will be using this monorepo project. So this is an Angular application, and in this I have many projects, and I will be adding DSA visualizer as another project in this application. But in your case, you will be creating a new Angular app. So you can go to the Angular documentation on how to create a new project, Open your Chrome and write create Angular application. So you'll go to the create new project, and in your terminal you will simply write this. And after creating this application, okay, we'll go to the Angular Tailwind, because we are going to use Tailwind in this Angular application. So open this. If you have already created this project using the command I show you in the previous website, that's fine. And if you have not created the project, then you will simply new your project, that is new DSA visualizer. Then you move into that project, then install the Tailwind, and then create this file .project css.src.json at the root of your project, and insert this text inside that file. Now you should use Tailwind CSS, because we are going to use SCSS. When you generate ng new DSA visualizer, there will be number of options which I am going to show you when I will add the project in my monorepo. And those steps will be same for you as well. So you will import the Tailwind as @use Tailwind CSS. So now let's see. Okay. So that's how I'm going to add an application to my monorepo project. So ng generate application DSA visualizer. In your case, you will add ng new and DSA visualizer. Then it will ask you what type of style sheet you are going to use. So we'll use SCSS. And then do you want server-side rendering? No, we don't want server-side rendering. It will be fully client-side rendering. Okay, so I have added this DSA visualizer as a project in my monorepo. Here you can see it. Now in your case, you have to do one more thing. The first thing is that you created the new project. The second thing is you added the Tailwind. And the third thing is you have to add the Angular material. So let me show you how we are going to do this. Go to the website and you will write Angular material. Here go to the Angular material component library, then go to get started, and here you will see this command ng add at Angular material. After you do this, the Angular component library is installed in your project. So then latest version of Angular is also 21, as I said you in the video. Okay, I am using Angular 19 because my monorepo project is built on the top of Angular 19. Okay, so in your case, you can use the latest version. It will not impact our project because we are not making something that is dependent on the versions. So we have created a new project. We have added the Tailwind. We have added Tailwind, and after that, we have added the Angular material. Now let's start this project. So you'll go to the package.json. In your case, you can simply write npm start because that's the only project you have, but in my case I have many projects. So I'll add another entry for my project, that is DSA visualizer, and here I will serve DSA visualizer, and I will run this on port 5300. Configuration, let's keep it development. Okay, so I'll write npm run DSA visualizer, and that's it. Our project is running on 5300. Now let's see in the styles.css part. As I told you, will be use Tailwind CSS. We'll close the other files. Now inside the app component, clear everything, clear the styles, clear the component, remove outlets, and this is our fresh project. So that's our fresh project. Okay, so we'll first create the UI part. Okay, the minimal UI part, and then on that part we will build upon the components that we require to create this project. Okay, so first thing, we need a tree component, and then we will need a tree node component. So tree component means that this component will generate whole tree depending on the input that we provide and the number of childs we will provide. So we'll create a tree component, and inside the tree component we will have the nodes. Okay, so we'll create another tree component, that is tree node. These two components will together create the whole tree. So we'll switch the terminal and then we'll add a component. So how you add a component or you generate a component in Angular? So right click on your project, absolute path, and you go to that path. Okay, now you write ng generate, that is short for generate G, and then component C, and you will write tree and press enter. Okay, then you will generate component tree node, but this component will generate inside the tree component. So move inside tree and ng generate tree node. So now we have two components. The one is tree component and the second is tree node. Okay, this is generated outside our source, so that's our mistake. So pick up this tree component and move inside the app, and we'll refactor it. Okay, so it's creating some problem. Let's just delete this tree part and create once again. So cd inside this DSA visualizer will go source app and then generate the tree component once again. Cd into tree and generate tree node. Okay, so now we have tree component and tree node component. So now we have these two, and now inside the app component we'll create a div and use that tree component here. Import it and use it. Write class flex and we'll place it in center, item center, justify center. I'll give padding of 12, height of dynamic viewport height, and width as dynamic viewport width. So we'll import the tree component. Now we have this tree component. Now let's work on the logic part. Inside the tree component, this is the core of our applications. This will take the input, this will take the number of the childs that tree node will have, maximum childs. Okay, and then it will build the tree out of it whenever something changes in the input string. Okay, so let's first understand what does a tree look like. Okay, so in structure, how are we going to grow the tree on the UI depends mostly on the how does the tree will look like, because a wrong implementation will create like a laggy UI. Okay, so we'll have to improve the performance on which the UI is built so that it is instant, there is no lag, and it should work smoothly. So let's first design what does a node of a tree look like. So when we are practicing the DSA, we simply have the tree node which has the left child and right child, but we have the child, which means it can has n number of childs maximum. So how are we going to do this? So a tree node looks like this. Okay, so a tree node has some value which can be any, it can be a string, it can be a number or anything. Now that node, this node, for example 1, it has a value, right? Then it has childs. How many childs? 1 2 3 4, n number of childs it can have. So we'll write a child's property, which is again, the childs are again what? Nodes. So these are nodes, that is array of nodes. Now what? Now let's say you inserted this tree in the UI. Okay, then you will insert this node, then you will insert the left node, then you will insert the right node. So you will build this tree on UI as level by level. First you insert one, then to second level, then the third level you will insert in the UI library. So first the 0th level is inserted, then the first level, and then the second level. So now my question is, if you are inserting these level by level, so when I say I have this node, but I have the information like it has this value, it has these childs, this is the first child, this is the second child, but do I have information about what is that element that is visible to the people seeing this UI? So the third thing that we have is the root. So the root will be this element inside the DOM tree. Okay. Then the third thing we have is lines. So what are these lines? A root knows where should I put the lines. Okay. So this node at root knows that I have to put a line from this to this child and from root to this child. Then this root knows that I have to put the lines from this to this node and from this to this node. A root store all the lines it has from itself to all its childs and not the reverse. A child will not store the line from itself to its parent. So when we will implement this, you will be able to understand more clearly, but let me show you why a root store the lines, the physical lines, the HTML elements, and not the child storing the parent. So when we insert this node this node knows that I have to insert two lines, one to this node, one to this node, but these two nodes are not yet inserted inside the HTML. Now when this node is inserted inside the HTML, this node will tell its parent, hey, I am inserted inside the UI or the DOM tree, and now you can give me a line from yourself to me. So when this node is inserted, it will send an event to its parent. Hey, I'm inside the DOM. Now you can insert a line between us. So this root node will now insert a line between itself and the child. So this line is inserted. Now this node will be inserted in UI and this will tell its parent, hey, I'm inserted inside the DOM. Now you can put up a line between me and you. Similarly, this child will send an event to its parent. Okay. This child will emit an event to its parent and tell them that you can now insert a line between me and you. Now one more thing, whenever the input string changes, we will destroy the tree and create a fresh new tree, and we want this instant. So for that, we will be using this as a structure of every node. So every node has a value to display, every node has the childs it shows, and that every node has a root, the HTML element that it is connected to, and the lines it has drawn. Okay. So now let's move on to the implementation part. So we'll create an interface, export interface, that is tree node. It has a value of any, it has a childs that is nothing but tree nodes. Then we have root, which can be null initially, but when the child is inserted inside the UI, we will have the root element, that is HTML element. And finally, we will have the lines from itself to its child. These are also null initially, but later on they will be added. Now why is it map? I'll tell you why is it map and not a list. Because in lines, when we use the map, it will be easy for us to find which line. Okay. So when we will implement this, you will be able to understand it more clearly. But as of now, let's see that these lines are map from source to target. Okay. Now we'll create a tree. So tree is protected tree and it will initially obviously be null. So we don't have as of now any tree. Now the part that will accept two things. The first thing is the input string, that is level order traversal of a tree, and the second is the maximum nodes that a tree node can have. So inside the constructor, we'll have to listen for those two inputs, and whenever those inputs will change, we'll build the new tree. So we'll have two controls, that is nodes control, that is new form control of type number, that is count of maximum nodes a node can have. So we'll give a default value of 2, and then we'll add validators on it. Validators dot minimum of 1, and maximum it can have any. So this is our control for the count of nodes. Then we have, okay, let's give it a name, child count, child count control, and this is nodes control that will take the nodes from the user, that is nodes string from user. Okay, by default it will be an empty string. And now what we want is, we want to listen for the changes of these nodes control and child control. So first we'll combine latest from RxJS, and we'll combine the observables of these two elements, that is child count control dot value changes, and nodes control dot value changes. Okay, now the thing is, we'll subscribe to this first, then we'll subscribe, and then we'll have two values inside this. First is, that is child count, and then the second is nodes. We'll accept this. Okay, now the thing is, when this application will start, we won't be having any child count and nodes, and there will be no tree. Okay, so initially what we can do is, so one more thing, that's not a problem, because initially we don't have any child count control, we don't have any nodes control. When user will insert the child count, it should build up the tree. But the problem is combine latest. This operator will trigger whenever, when only both the childs will emit at least once. So we'll initially emit these from these. So we'll pipe and start with maybe the child count. We can start with minimum of 2, and similarly we'll pipe for this and start with an empty string. Okay. Now we'll initially get child count and nodes count, and based on that we will build our tree. So we'll create another function, that is parse and build tree. So we'll get the nodes. Okay, then we'll do math dot maximum of either child count is the maximum if it is, or 1. We won't be accepting the negative values. Okay, then we will create this function. So this will be private function. It will accept nodes row value, that will be string or null, and then we'll accept the child count, which will be number, and by default it will have a default value of 2. Now we'll get the nodes, that is nodes row or empty string. We'll split this by space, and then we will filter all the values that are not null. So values, or we can say empty string, too many gaps between the numbers. So we'll filter by space, and then when we divide by the space, there can be numbers that are invalid. So for invalid, we'll simply write that whatever we are getting, it should be a valid, not empty string. Okay, so we'll trim and we see that it should have a length. So now we have the nodes, and if there is no nodes length, this array is empty, then we will delete our current tree and we will return. Okay, now we will initialize the tree. Else, in else case, we will initialize our tree this dot build complete tree. We have these nodes. From index 0 we want to build this, and we have child count. So we'll write another function, private build complete tree, and inside this we'll have the nodes. So we have nodes of string array, then we have index, that is number, and then we have child count, which is also number, and it will return tree node, the root node of this tree. Okay, now let's also create a dummy node. So private dummy node, which will return tree node return, whose value will be null, and childs will be this. Okay, now if we write that if childs not nodes dot length, or if the index is greater than equal to nodes dot length, then we will return this dot dummy node. Okay, this is the null node. Okay, now let's say the node is value is nodes at index, then we have childs. So the childs will be array dot from the length of this array should be length of child count dot map, and initially each element is a null node. So each child of this node is a null node. Now we will see if we have the child for that particular position. So we have created this node with a value of nodes at index. Now for each child means child count. For example, it is 3, then it will have 3 childs, and by default all the 3 childs are null. Now we'll see if we can replace that null node with some other node. So for let I is 1, I is less than equal to child count I plus plus. So node dot child set I minus 1 at ith position, I minus 1th position, we will recursively build that child. Okay, so we'll call the build complete tree for nodes, and what will be the child's index, that is for example in binary tree we did 2 into index plus 0, 2 into index plus 1, sorry, 2 into index plus 1 and 2 into index plus 2. For 3 it is 3 into index plus 1, 3 into index plus 2, 3 into index plus 3. So here it will be child count multiply the index, that is idx plus 1 plus 2 plus 3, so that is I. Okay, and finally the child count. So we have inserted all the required childs, we have replaced all those childs. Okay, so we have for example three childs, then at 0th child will be this, and 1, and then second child. So this will build all the required uh, childs of this particular node, and after doing this we will return this root node. Okay, So building of this tree is completed here. Now it says something else, that is property child is missing the type value child's tree node array but required type this. So I think we did something wrong. It is not childs, it is childs. Okay, let's return childs as an empty array. That's it. So now we have created our tree. So let's recap what we have done. So we'll listen for count of the childs, we'll listen for the nodes control. Whenever any one of these two will change, we will create a new tree. So what it will do is it will pass these nodes and then initialize the tree. So tree has been created. So now is the part for the tree component HTML part. So here I told you that we took the control for nodes child count control and the nodes control itself, but we don't have the UI part itself. So now let's create the UI part. So inside this div I'll be having another div for the controls and this div for the tree part. So inside this we'll have tree node. Okay, so here we give class width of full, height of 80, dynamic viewport, height, overflow, auto, relative, and flex of 1. So it will take up 80 dynamic viewport height, this tree, and the rest of the height will be taken up by this div. So we will give it as width of full, and for the parent we'll give width of 80%, margin of auto. So here we have class of flex and height of auto, and we will show this tree only if we have the tree initialized, and after initializing we'll pass the node to it. So this app tree node, this is the node, which node it should build. So the first node it should build is tree itself. Now inside the tree node you will insert this as create an input node. Okay, we have created the tree node as an input node, and we will not accept this as a tree node, but as of now let's accept this as is. Okay, so now we have this node, and let's say this is a tree node. Okay, now inside the tree node we will build the tree recursively. So we'll use the div again, and I'll let you know why we are creating these divs. So this is the root. This is actually the circle node, and this one is where we'll render the childs. So this div here will render the node's value. So here we have node.value, and inside this part will render all its childs. So how do we render it? Can you guess it? So we have created this node, and this node has childs. All those childs we have to render below it in the next level and recursively. So we'll use the same component. We'll use tree node inside tree node to render its child. So what do we pass? We'll pass the node, and inside this we'll pass the child. So we will recurse for the child. So we'll use ng4 let child of node dot childs. So for each child we'll build this. So now we have this. Now let's see what's the result of this. But before that we should be accepting the inputs, but without doing that we'll, let's say, give 1 2 3 4 5 null 6 and 7, and a minimum of 1, and a default value we have given as true. So now let's see. Okay, so nothing is rendered, and the reason being, we'll go inside this, we have a tree component, and I think we have not used it. Okay, we have used the tree component, and inside that we have a tree nodes control, nodes child control. Whenever something happens, we'll parse and build the tree. We'll move on here. We'll completely build this tree. Okay. Okay. So let's see what's happening in here. We'll go to sources. You can use Control P to search for the files, and in our case we'll be using tree component.ts, and inside this tree component.ts we'll have to use a breakpoint here and see what's going on. So we got here our nodes is an empty string, and this is true. Why is our nodes an empty? Okay, because the default value we have started with pipe of what, nodes control with the pipe of start empty string. So when we give the default value to this nodes control, this is not emitted by default. Okay, so we'll first emit this. So inside that, let's remove this part from here, and what we'll do is after the first emit we'll do this dot nodes control dot set value. So we'll do set value of this with an emit event of true. We want to emit this event. So here you go, the nodes are rendered. Okay, 1 2 4 7 null null null. So now let's design these nodes. So you go inside the tree node component. So first we will design this tree node. So we don't want anyone to select these nodes, so we'll do select none, and then we'll do flex of column items center justify center. Okay, now we will design the node part. That is a class of z index of 50. This is a node, so we are giving it a custom class that is node, so that we will be able to find this node to assign to the node interface. Okay, we'll see it later. Background of green 400, we want it rounded full, padding of 4, aspect ratio of square, flex items center justify center, and a text of 2xl. So that's the node part. Now let's see. So I think the tailwind is not working. Okay, so seems like our styles are added to the element, but they are not working. So let's see what we have done. So we have created this post src file, and inside the styles we have used tailwind css, but I think we missed this tailwind config.js, which is required. So we'll copy this part and we'll put this inside the root of the project. So inside the DSA visualizer we'll insert this. So these are container queries, we don't need it, so you can insert this structure inside the tailwind config.js. So we'll start the DSA visualizer again, and now you see our nodes are rendered perfectly. Okay, so these are our nodes. Okay, these are in circle but they are overflowed, so we will look into this later. So first, now let's design the child section. So inside the T node, this is the child's part. So we'll have a class of flex in row, not in column. So the childs will be in a row. We want the items to be at the start and not at the center. Okay, because the height of the child's container can be large, and we don't want the childs to be at the center of that container. It should be at the start of the container. So let's see. So this is the design of our tree as of now. This is the root node, these are the childs of it, but they still don't look fine to me. So let's give this tree node a margin of 4. Okay, uh, seems fine to me. So one has two child, that is 2 and 3, then 2 has a child of 4 and 5, 4 has child of 7 and this null, and then 7 has two childs, null and null. So this is how our tree looks like. Now let's do one more thing. We'll increase the gap between root and its childs. So this is the root, this is their child, left and right. This is root, this is the left child, and this is the right child. So we will increase the gap between these childs. So we can write style dot gap in pixels, and let's say 64. Now let's see. Okay, so inserted and given the enough gap in each level. So this is how our tree looks like. Now the pending part is inserting the lines between these nodes. Now how are we going to do that? So I told you that when this root node is rendered inside the UI, this node cannot insert the line between 1 and 2 and 1 and 3, because root node is inserted, but like at the time of node 1 is inserted, the node 2, 3 and all the nodes below it are not yet inside the UI. So we'll use the reverse approach. We'll ask the nodes 2 and 3, hey, whenever you are rendered, just tell me so that I can give or create a line between you and me. So that's the logic we are going to use to insert the lines between these two nodes. Okay, so how are we going to do this? So this is the tree node. A tree node will tell its parent, hey, that I am rendered inside the UI. Now you can insert a line between us. So we will be creating an event. So that is rendered. So this event will be fired whenever this child is rendered inside the UI. So we'll do this, and inside the tree node, we'll create an output event rendered, which will be new event emitter of type tree node. So it will tell its parent, hey, this is the node that is rendered on the UI, and we'll create a function that is on render. On render, we will get the child, which child is rendered. Okay, so this is the parent, this node is the parent, and this is the child. This child will tell its parent, that is this current component, will tell that, hey, I am rendered on the UI. Now you can do or you can insert the line between me and you. Okay, so if this child does not have root element, will return. So what is root? So let's say this child is rendered. How do we know this child is rendered? So this child will implement after view init. So whenever the view is initiated, we'll be able to know, okay, this child is rendered. So ng after view init, we will write inside this node. When this node is inserted in UI, this node has a root, which means this node must be having a UI element. Okay, so what is that UI element? So now that element is we are going to create. So that UI element is this. So when this node is rendered, this is the UI element that gets rendered, right? So we have node root. Now we'll use this node root inside the TS file, view child, node root, and we will read it as a static. So node root will be element ref So what's wrong we are doing? Okay, node root is element ref of HTML element. So this will be there for sure. So whenever this element is rendered, we'll say, okay, the root of this element is this dot uh, node root dot native element, and then we will emit to its parent, hey, I am rendered. So render dot emit this dot node. So when this node will emit to its parent, so when this node will emit, someone will be its parent, and the parent will also be pre-node. And on pre-node, whenever this event will came, the onRender will be called, and inside onRender we will get the rendered node. So it must have child.root. If it doesn't have, we cannot do anything, but it will always have. This check is like useless here, but it's just a safety check. Okay, so on render we will see, like for example, if a node has 4 childs, okay, so when should we draw lines? We have two approaches. Either draw this line, then when the second child is rendered we draw that line, when third child is rendered we draw that line, or we have another option. We'll see, if all the childs are rendered, then only draw these lines at once. So we'll follow the second approach. When all the nodes or the childs of a node are rendered, we will draw the lines to them. So first we'll check if this dot node dot childs dot some childs does not have root, then return, which means if any of the child is not yet rendered on the UI, we are not going to draw the lines. Only when all the childs are rendered, we'll draw the lines. When all the childs are rendered, we'll do the child of this dot node dot childs. We will draw line to this child. We'll create another of this function. Let's do this as a protected function, and another of private function, draw lines. It will accept child, so we'll draw a line to this child. Not tree component, it should be tree node. Now we have child node as child dot root. This is the root of the child. We'll select query selector. We'll select the node out of it as HTML element. Okay, so first let me write the logic and then I will explain you what I'm doing here. So if there is no child node, I'll return. Okay, so let me first show you the UI so that you can understand it. Inside that, if I inspect, you see this. So this is one of the portion where this one will represent the, so if you go here, this is the tree node. Inside that we have this div. Inside that div we have the first node as the root and the second div. So the first div is the root and the second div contain all the childrens of it. Okay, so when we write the node root, the node dot root, then that this element is that node root, and when we query select the node, then we get this node. Okay, so the child root inside our row lines, that child node is this node. Okay, so we have this as a root, this as a root, sorry, this as a root, and this node, the element with the node class is the actual node. Okay, so we got this child has a root and that root has a node, so we got the child node. Now node element, so this dot, this is the parent, this is the current node we are talking about, so this is the node root. Okay, and this also has a node element. Okay, so when we go inside the tree node, we have this node element. So let's write this. So we'll do node element. So inside this we'll replicate this node element, which will also be static of true. And let's write this node element of this. Okay, so now we have this node element inside the draw lines. We have this node element. This is node element dot native element as HTML element. So this is current node, or we can say parent, and the root is current node's root. Okay, root means the container outside the node element. This dot node root dot native element as HTML element. So this is the container around current node. Okay, now we have two nodes on which we want to draw lines. So the first node is, let's say P1, that is node element. Okay, the current node, the first one is node element, the current node, we get the get bounding client rect of this node. And then we have P2, that is the child node. Okay, child node, this is P2. And the root node, the current node's root, or we can say the container outside the current node. So we'll do root rect is root dot get bounding client rect. Okay, now is the fun part. Now how should we draw the line between P1 and P2 inside the root rect? Okay, let's first understand one more thing. For example, this is our container around the node. So this is our root container. If I go inside the childs, I'll see that this is one of the node, this is another of the node, and inside this node we also have this container, right? So this container has this node and this child elements. So this is recursive. Okay, now what I want to say is, if you want to insert the lines, okay, so for example, you from 1 to 2 you will insert a line. So we want that whenever we scale this screen size, we want that line should be stay in that proportion. Okay, so we don't want to draw it globally. For example, this is a relative element, and relations to the viewport, we don't want to draw in relation to viewport, but we want to draw lines in relations to the container. So for example, this is a container. If we create this as a relative element and we insert the lines inside that container in absolute position, whenever this child resizes, this container resizes, the lines will stay in that proportion. Okay, now for example, here is another container. We will insert the lines inside this container. So my point is, we are not going to insert all the lines in the root container, but we will insert the lines inside their respective containers, or in the app tree node in this container. Okay, so we will draw these two lines in relation to this root. So if this line is drawn, this will go inside this root. Okay, now to draw a line, we should know the coordinates, that is x1, y1 and x2, y2. So let me show you. Okay, so let's say this is our node 1 and this is our node 2. This is our node 3. Now we want to draw line this way and this way. How are we going to do this? So we have some coordinates. Let's say this is x1 and this is y1. So this is our node container. Okay, this is our node. This is our node child's container. So this is our root, right? Root container, and this has some x1 and y1. This is our viewport. and like this, and to the roots container in relation to root container from this point. So let's say what is x1. So what is x1 with respect to the root container and not the viewport? So this is, let's say, p1 and this is, let's say, p2. So p1 dot left, this will give us this width. So p1 left, okay, plus p1 width. So left will be always from, so for example, if this is the node, we'll create a square outside it, okay. So this will be left from the left edge to the left of this viewport. So this is left plus the width plus this width. So we'll write p1 width by 2. So when we do 2, we'll get the length from this point onwards to the center of this node, okay. Then we will subtract root container that we have the left of it. So this is our root container and this is our left, this part. When we subtract this, what we will get? We will get the width from here until the center. So this is the width that we'll get. So this width is relative to the root container. So that will be our x1, right? Similarly, we'll have y1, that is for y1, we have this width until center minus this width. So we'll get height in relation to the root container. Okay, so we'll have x1, y1, x2, y2. Now let's see this. So we have this and this, and we have this and this. Now we want to find this. So how do we find this? First we'll find the length, that is square root of first is this is x2 minus x1 and y2 minus y1. So x2 minus x1, what will it give? So this is, let's say, x2 y2. So x2 minus x1, what will it give? The distance between these two lines in the x axis. So this will be x2 minus x1 and this will be y2 minus y1. Okay, so we have this and this. So we'll do the different square. So let's say this is dx and this is dy. So dx square plus dy square, and the square root of this will give us this slant height. Okay, and that's what we want. Now we have the length of this slant, but we still don't know what is the angle at which this line will stand. So what is angle between this node and this node? So what is this angle that we want? So angle is the tan theta. So we'll create the angle between dx and dy. So we'll use the mathematical formula to get an angle out of. So we'll use this math.8and2 function to calculate the angle between these two nodes. And we have to also check that the angle should be left tilted or right tilted. So let's implement this. Okay. So first we'll get the length. So first let's find the coordinates. So let's say x1. So x1 and y1 will be of p1. And what is p1? P1 is current node. So from current node, and x1 y1 is current node, x2 y2 is the child's node. Okay, so let's say p1 dot left, p1 dot width by 2 minus, that is root rect dot left. Okay, so we have y1, that is top, height, top, and then we will have x2 as p2 dot left, p2 dot width, and root rect dot length. Similarly, it will be left cut top height of P2 and top of P2, and this will be Y2. So we have these coordinates of the node P1 and P2. Now we will find dx and dy. So dx will be x2 minus x1 and dy will be y2 minus y1. Now the length will be math dot square root of dx multiply dx and dy multiply dy, right? Now angle. So angle will be math dot a tan 2 dy by dx multiply by 180 divided by math dot pi minus 90. So dy math dot square root of dy plus, and we got an angle, and now we'll draw the lines. Now I told you while creating the interface of that tree node, so in the tree node we has the root value, we has the element associated inside the DROM tree, and then we have the lines inside it. So if there is no lines, then we'll do this dot node dot lines as new map of HTML element. So it will be helpful for you. For example, if you want to render the tree, for example, whenever window resizes or anything, so in that case you should be able to remove the old lines and insert the new lines. In this approach, we'll first, if there is no lines map, then we'll create this map and we'll create a line. So line will be either an existing line dot get that we have created for this child node. Each child node have an associated edge from itself to their parent. Okay, so for this child node we should be having a line from itself to its parent node if we have created this in the past. Okay, so if we created in the past, then take that lines, else we'll create a new line. So created a new line. After creating a new line, at the end we will append this line inside the root. Also we'll set this line inside our node.lines cache, so that next time if we render, we'll use the same line and do not create another line. Lines.set to this child node and this line. Now the next time if we see that this dot node dot lines has this line at child node, then we don't render it again, we just update the CSS of it. Okay, we do not have to insert it inside the node if it is already there, else we'll set and append this child. Now this line will have some CSS, so line dot style dot CSS text will insert it as this. So this will have position of absolute. Okay, and from the left of what we have created these x1 y1 x2 y2 in relation to root container. So the left will be in relation to root container. So what it be? So it will be x1 pixel, then from top it will be y1 pixels, then the height of the line will be the length pixels, and width, let's say the line width is 2 pixels, background is, let's say, grayish color, then transform origin will be top center. Oh, okay, this is an important point. Transform origin is not center. So when we create a line from the child to its parent, the one end of the line is at the top child. Okay, so this line will rotate an angle from the top center. Okay, I hope you get it. So it will not rotate from center. It will rotate from top center, the top of the line, and will transform rotate at this angle, degree, pointer events none, and z index is 1. Now we have inserted and created these lines, and now we'll see the UI. Okay, so this is our UI part, and we are still not able to see our lines, but still let's say this is our container, this we have nodes, and this is our child container, and inside this we should be able to have the lines, but we are not able to see those lines. So let's debug the issue. Go inside the source, and you can use the breakpoint inside the tree node. So tree node component. So whenever a child is rendered, we'll be using draw lines, or on render is called. So we'll use this and we'll refresh our. So you see this child is rendered. Which is this child? This child is rendered. And when this is rendered, it will call its parent that, hey, I'm rendered. You can draw a line between me and you. Okay. So this child is rendered and we are returning. Okay, we are saying that if there is a root we return, we should not be doing this. We should do the opposite. So when rendered, if there is no root, we will return, else we'll draw. Okay. Still there is an issue, and let's see what's the issue now. So we got this, and we are returning because not every child is rendered. So it has some childs. There are two childs. Okay, so the first child has this root, this one, and the second child is not yet rendered. Okay, so we'll wait for the second child to render. We'll go next, and this has two childs, and both of these childs are rendered now. And we'll go forward, and for each child, we'll go inside the draw line. So this is child node. Okay, inside the child, it doesn't found any node. So for query selector, it failed. Let's see why. So we have this root and child.root. We have this child.root, and inside that we are not able to find any node. So we'll have to see this. So this is the element, and here we have this node class. Okay, just go to console and print this. You will get this element, and inside this this element itself is a node, right? So I think we are doing something wrong. We are assigning node itself to the child.root, which is wrong. We have to assign the root of that element. So this is node root. Okay, so node root is assigned as node element. So this is node element, and this is node root. Okay, so now let's see. These lines are rendered perfectly. Okay, but they are not like aligning to these elements, and the reason being this element is maybe not relative. So position relative will have to do. Okay, so let's do for all these node containers. Okay, so inside the tree node uh, inside the tree node we want the host element, that is tree node, to be position of relative and display of flex. So now the lines are pretty in place, but still they need some modification. So now let's see what we are missing. Inside the tree component, we'll get this component as height of full, width of 100%, I'll give margin of auto height full here also. Flex of column, gap of 4, items should be at center, overflow auto, and justify center. Okay, so we have this node container, we have this node, we have these children's, and we have these two lines. Okay, and these two lines are in absolute position with respect to this container. And I think we have done some mistake in calculating these positions. So let's look at these calculations once again. So we got this child node. If there is no child node, we will return. We have this node element, the root element. So the node element is this, and the node root is this one. Child node, we got the p1, that is node element, child node, rects and root rects. We got our x1 is p1 left, p1 width by 2, and root rect dot left, p1 top, height top, and p2 left, p2 width by 2, and dot left, to top, and p2 height, width height, and by 2 minus root rect dot top, and is x2 minus x1, y2 minus y1, dx square, dy square, and then angle is dy by dx multiply by 180 by pi minus 90, and get the nodes dot line. Position absolute, left is x1, top is y1 dot pixels, height is length, width is 2, background is grayish, angle pointer events none, and z index is this. Okay, so I think this is the missing, so transform origin was wrong, and let's see. So in our case, transform origin is top center without any hyphen. Okay, so our tree is rendered perfectly fine now. Let's move and remove that set timeout thing. Okay, so now one thing that we have to do, whenever the tree is destroyed, right? So whenever the tree is destroyed, our lines are still there and we create new tree. Okay, so when I say, for example, this node is destroyed, so the lines from this to this node should be destroyed, and we want this automatic. We don't want that if, let's say, tree is destroyed, we will pass through all the lines and destroy it. Let the node itself do its work. If this node is destroyed, it will also destroy its lines. So let's implement that logic. So this is the node, and if it destroys on destroy, if this node get destroyed, what should it do? So here we'll do on destroy, we'll call the reset function for this node, and what this will do is node tree node for this node, and let's take it optional. If not node will return and node dot lines dot, for each line we will remove the line. Okay, node dot lines will be new map. Now you see we have created these lines for this only, to keep track of the lines that we have already created. So for example, when this node will be destroyed, we will destroy its lines too. Okay, now let's see the view once again. So this is the tree that is created itself. So it has 1 2 3 4 5 null 6, and it has 2 null also. So this is for you, the task is for you. Now what we are doing is we are taking an input string. The input string can be anything, literally anything. So you can have, for example, your name at node 1. So this n means nothing here. You are giving me a level order traversal 1 2 3 4 5 null 6 7 null. So these nulls are auto inserted into the tree. So let me show you. So when we were building the tree here, parse and build the tree, we have created this dummy node. So when is this dummy node returned? So if the node length, there is no length, or if the index is greater than node's length, which means the child is null, at that point we will return this dummy node. So we can return something like x, which means this is the end of there is no child here. So if you see, these are x and this is n, which is what's there inside the input string. So if you really want that the numbers, that the input should be number and n means the null, then you will have to like check for the validity of the input string, and I will be putting that onto you, so that you try out how should you handle this. Currently what I'm doing is I'll take the string and I assume that whatever you have given me is n level order traversal of the tree. But for example, someone might give you 1 2 3 4 5 null null, and then it again give you something that is child of that null. In that case you should throw an error and say that you have given me a traversal which is wrong. A null element cannot have childs. Okay, so those validities I am leaving up to you. I have created this simple implementation in which I have been given the complete level order traversal. I render that inside the DOM. That's what I am doing. Now let's take these number from inputs. Go inside this. Okay, so inside this tree component here, we'll create those inputs. So first input here div, and then we'll create a button also to download the tree. So we'll create a button, that is matte flat button, where the color will be primary, and it will only be visible if there is actually a tree. So this is a button, and if we write ng if tree, also download button. Here inside this we'll write class flex items center and a gap of 8. We'll create mat form field. You can pick up these from Angular material website. So you go here, you will search for Angular material, Angular material, components, form field, and examples. You go here and you copy this code and paste in here. So we have this label input, mat icon, mat int we don't want. We have mat input, appearance is fill. Okay, go inside the tree component and you should import this mat form field. Okay, let's say traversal. Okay, and the form control will be nodes control. Similarly, we have another control for nodes count control, child count control. Appearance will be fill, and this should take up most of the space. So class flex1 and width full. Let's see. Okay, so it says mat label is not known element. Go inside the tree and import mat label. Okay, here you see. So here is our input and the input is 2. So let's see. We'll write 7, or from again we'll write 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now what's the problem here? You see the old lines are not deleted. So what could be the reason? So if you go here inside the tree node, you will see that whenever this input is changed, the node is changed. Okay, the new lines are created for this node because the tree node, because whenever we change the input, you go inside here, if you see, whenever we change the input, we build the entirely new tree. Okay, this input is changed, the destroy will not be called here. Okay, because only the input is changed, right? So we'll have to destroy these lines and this node, these lines, whenever the input changes. Okay, so that part is, will separate out private root as tree node, and then we'll take this input, set node as node and tree node. Okay, and this dot reset for this dot root, because initially the root will be null. The reset will return from the first line itself, and for the next changes it will destroy all the lines. So this dot root will be node. Now we'll see. Okay, so it will be 1 2, something is wrong, and that says cannot read property of undefined reading on container click form field. Properties of undefined reading on container click, reading value. So it is reading val, and let's see, tree node has a val property. Okay, there is no getter, we forgot, so we will create a getter also, getter for node, and it will return this dot root, and it will return the tree node and Let's see now. Okay, our tree is up now. Let's say 1 2. You see all the lines, all lines are deleted. 3 4 5 6 7 8 9 10 11 12 13 14 15. So you'll have to just uh, slide and see the whole tree. So tree has been rendered. Now we'll change the number of childs a node can have. Let's say 3. So now you can see each node has 3 childs. Okay, so this 5 has 3 childs, 14 15 and 1 is null. All the childs after that has null as their child. Okay, so 14 has null, 15 has null, 5 has third child as null, 6 has all the 3 childs as null. So our this part is completed. Now the next part is, first we reload it. So the first part is this. Initially we have this traversal and the count is 2. So you can change the what you can change the label as child count, or you can say max. So you can design these component as per you. What I did is I have implemented the functionality. Now the next part is downloading this tree as a PNG image. So we have created this button, download button inside the tree component, and now we will download this. So whenever this button is clicked, so on click, what do we do is we have to save this division. So tree element dot native element. So we'll save this tree node, the root of the tree, that is tree container. Okay, inside the tree we'll write at view child of tree container. We want to read as element ref, and static is false because it might change depending on trees null, undefined, or if it is initialized. So tree element will be element ref of HTML element. Okay, so we pass the element and we want to create this save div function now. So we'll create protected save div, and inside it we'll get a node that is HTML element. Now we'll get the parent of this node dot parent element. Now when we save something, so you know that in HTML is rendered, so what's visible on the viewport. So if you have a list, scroll list, so if you try to capture or save that element, only the visible part is saved. Now in our case, our tree can be very large, okay, and in that case some tree might be hidden. So we, while saving, we want that the tree is fully visible, and when it is saved we will restore the old scrolling properties. So first we will save old height, old width, and old overflow. So we'll save old height will be what, parent, that is the on which it is scrolling. So parent dot style dot height, and old width, so old width, parent will always be there, and old overflow will be parent style dot overflow. So this we have saved, and now we will change something. So for the parent style dot height, the height will be parent dot scroll height. Okay, and width will be parent dot scroll width. Parent dot overflow is visible. Now when we have changed this style, they will not be applied instantly. So we will wait for the next frame. So we will wait new promise, and this has to be async function for await to work. Then we have resolve and reject, and we'll do set timeout. For the next frame to be rendered, I will call the resolve. Now we'll create data URL, await. Okay, we will be using HTML to image as the library. So switch your tab and use npm install HTML to image. Okay, after installing, import star as HTML to image from HTML to image. Okay, now move to save div. After saving, we'll write HTML to image dot to PNG. We will save this tree as a PNG image without any background. So we'll save the parent element in which there is that. So this is the our tree, and this is the parent element. Okay, this is the parent element that we are going to save. So we'll save the parent element, and the quality will be pixel ratio. Will make it to high. It depends on your machine. Pixel ratio of 8. Now we will restore the old values of after saving. I will restore old values. So it will be old height, old width, and old overflow. I'll create a link document dot create element anchor link dot href will be data URL, then link dot download. I will download it as tree.png and link dot click. Let's see if this works or not. Okay, so we have this. Now let's say 1 2 3, and if I click on download, it's downloaded, and this is our tree, right? Now let's do something big. So I'll create a big tree. I will click on download and go to this. So this is our tree. Okay, okay, and let's see, for let's say 5 childs, and download it. Okay, so this is our tree which has 5 childs, 1 2 3 4 and 5. Let's make it smaller. Okay, download. This is our tree, so it has 5 childs, each element has 5 childs. Now the best thing about this is you can customize it as you want. So for example, I want my childs to be ABC, B, C, D, E, F, and I told you that I am not doing any validity on these elements. What I am expecting is whatever you are giving in the traversal string, it is the level order traversal of that tree. Now if you want validation of that traversal, that I am leaving it on to you. So take the string, do whatever you want to do, check validity and modify in a way you want. This implementation will be able to generate any kind of the tree. Okay, any kind of the tree which you want. Okay, so if you don't want to display these leaves, you can return the null. In case of that dummy nodes, the dummy node that we are returning, you can change some implementation on that. Okay, if we remove everything, there is no tree, there is no download button. If you write something, there is a download button and you can click on that and you can generate. So you see the image generated is of around 1.3 MB, which is quite HD. Okay, so that's it.